In the previous video, you learned that you can assign an expression of one type to a variable of another type. This sometimes results in the loss of information because the variable cannot represent the exact value that results from evaluating the expression. Here we want to spend more time discussing the values and types of expressions. Let's consider this tiny C program. What do you think it will print? If you guessed 0, you would be right. Consider the right-hand side of this line. I has the value 5, and j has the value 10. So you might think that I divided by j has the value 1/2, so that when this value is assigned to the integer variable k, the fractional part is truncated, leaving the value of 0 in k. That would produce the correct 0 output, but that's not what's going on. Instead of assigning I divided by j to an integer variable k, let's assign it to a double variable d. Now what are you expecting to be printed? Was that what you were expecting? Let's break it down carefully. On the right-hand side of this line, integer I is divided by integer j, and the result of that expression has a value and a type. The important rule here is that the type of the result of an expression depends on the operator, in this case the slash for division, and the type of the operands, in this case both integers. In C, when we perform division on two integers, the type of the result is integer. I'll say that again because it is bound to trip you up at some point in your C programming career. When you divide an integer by an integer, the type of the result is integer, and this doesn't depend at all on the specific values you're dividing or the variable you're storing the result into. So in our program, the result of dividing the integer 5 by the integer 10 is the integer 0, not the floating point value 0.5. So in this line, the double variable d is being assigned the integer value 0. So how could we get a floating point result from dividing two integers? Surely we are going to need this regularly in our programs. Well, suppose we changed one of the operands in our division, either the numerator or the denominator, to be a double. Let's pick the numerator, but either would work fine. Now we see that k remains 0, but d now has the value 0.5. The type of the result of dividing a double by an integer is a double. But as we speculated earlier, if you don't have the correct value to store it in, it won't matter. But this solution isn't going to work for us all the time. Maybe we have other good reasons for wanting I to be an integer. Perhaps it represents something that can't have a fractional value. It would be bad practice to use a double for I just so that we could later divide and get a double result. Let's put I back to what it should be. Instead, we can tell the compiler to convert I to a double within this expression before doing the division operation. Let's copy the lines so you can see both versions. We put the type name double in parentheses before I. This is referred to as casting I to a double. It doesn't change I's representation in memory, but uses the double representation when evaluating the right-hand side expression. Let's run our code. We see that double I, that's like 5.0, divided by integer j, 10, gives us a double result, 0.5. And then, when we assign that to d, we keep the fractional piece. In summary, when you're doing arithmetic, you need to consider both 1, the location where the result will be stored, as well as 2, the type of the expression being computed. If you want the result of an arithmetic expression to be of a different type than the values used to compute it, you'll need to add a cast.